Okay, next we are graphing absolute value functions, which is so fun, right? So, on your reading and watching videos for this chapter, they talk about creating kind of a table of values. So, for example, setting what's inside the absolute value bars equal to 0, solving for x to determine your first value to plug in, and then go 1 higher, 1 lower, 2 higher, 2 lower. Plug all those in to find your ordered pairs. That totally works, but I wanted to show you kind of a fun thing. So I wanted you to see how the absolute value function changes as you change some things about it. So let's start with just f of x equals absolute value. Where is that? Not that one. Absolute value of x. Cool? So notice it starts right here at the 0. It makes a V, and you're going, there's intersects right here. So it's a slope of like up 1, over 1, up 1, over 1 in both directions. That makes sense because if you plug in positive 2, the absolute value gives you positive 2. If you plug in negative 2 here for x, absolute value of negative 2 gives you positive 2. That's why it makes a V. Okay? Let's play around with this. What if we were to add in a plus 1? What happens to the graph? It shifts up. What if we were to change it to a minus 1? It shifts down the y-axis. What if we were to change it to negative 6? It shifts down really far. How about positive 6? It shifts up really far. So this value out here on the outside of the absolute value bar shifts it up and down in the vertical direction, okay? What if we put something on the inside here with it, like maybe a plus 2? Notice when you put on the inside of the absolute value brackets a positive number, a plus 2, it shifted left. The reason is because if you plug in the x value of negative 2 here, negative 2 plus 2 gives you 0. Absolute value of 0 is 0, which is that output. What if you were to make it be negative 2? Notice it shifts it right. Okay, so this value, you might think it would do the opposite, that a negative number would shift it left and a positive number would shift it right. But the parent equation actually has a negative in it, so it's the opposite of what you might think. Okay, let's try something else. What if we had that negative 2, but then also had a plus 2 on the outside? So notice the negative 2 on the inside shifted it to the right 2. The positive 2 on the outside shifted it up 2. And I'm here talking about shifting just that vertex point or the turning point. All right, what if it was to be negative 2 on the inside but negative 3 on the outside? So again, that shifts the vertex right 2 and down 3. Cool. What happens if we change this to be a negative? It just changes it to open down. What if we were to make this be a 2? Notice it gets more narrow. What if we were to make it be a 1/2? It gets more wide. So this is essentially like the slope of the line. Rise up 1, run over 2, keeping in mind the scale here of this graph. So here's my vertex. I would rise up 1 box, run to the right 2, and same in the opposite direction. And a minute ago, it was 2. Let's see how that changes it. The slope is 2 over 1, so you rise 2, run 1. Cool? Just making sure that they are symmetrical. I think that's a more fun way to graph. So let's look back quickly at the example we have here. So we have on the outside a positive 1. So I know that's going to shift the vertex up 1. We have on the inside of the absolute values a positive 4. That I might think it goes to the right, but it actually does the opposite. So the vertex goes left 4, up 1. And it's a positive number, so it's definitely going to open up. So that doesn't look like the right vertex. We have left 4. And these are, each box is 2. So we have left 4, up 1. I believe it's that one. Let's try C. Yay! All right, you try it.